Hello everyone, my name is Hatem.
And my name is Amar.
For this project, our goal was to parse XML files that consist of EQ and SSH that are configured as a common information model. The task was to parse these files, store them in the database, and then also calculate the Y bus matrix and display it. Amar now will show you how to run the program and interact with the GUI and also display the data in the SQL.
So basically, we will start by ensuring that we have a database. So I will just click and type the password of the database. And as we can see, we have we are logged and the database is running. So now we will try to access it with our program. So I'm gonna just run the project first. So we will get this window which has like 4 buttons. The first two will allow us to import an EQ and SSH files. Third one will allow us to log into database, and the fourth one will be to execute our program. So we're gonna just start by loading an EQ file and loading SSH file, and then log into database by entering our login details, and then execute the program. And as we can see, we have here the Y matrix of the system. So if we are go and to the database and press refresh, we can see that we have a new database called project1 grid. If we can expand it, we will see all the extracted information here if we want to quickly check it. In this part, I will explain the user graphical interface which were created by Windows Builder Swing Designer tool in Eclipse. As we can see here in public project 1, we have a set of frame buttons and labels defined with a certain settings and specifications. For each button, we have assigned an action command and an action listener to perform a certain task whenever pressed. Whenever a button is pressed, one of these scenarios located in action performed method is taking place. In case of import EQ, which is action command number 1, a file browser will be opened where the user will choose the file, and the directory of this file will be saved and printed. As we can see here. And then a message in the program will appear. In case of the second button is pressed, it's exactly following the same structure as the first import EQ1. So when login to database button is pressed, then database log method is accessed. This method creates a frame that will serve as an input to database user checker. Database user checker will add label, text fields, and buttons to that frame in order to capture the username and password from the user, and then use user authentication to compare it with a predefined one and either return true or false. This true or false can be translated to Boolean using user logged or user not logged. If the username and password are correct, then establish the connection using these following lines with the database and enable the next button, which is execute and display a message. When execute button is pressed, this scenario takes place. It starts by creating objects for the classes read EQ and read SSH file based on the directory captured earlier. These are an extended version of the read XML example introduced in the class earlier. It utilizes Document Builder Factory and Document Builder to read an XML file and then parse it. For the create node list method, we are entering the method with a certain tag name and then to create a data list for the elements that has the same tag name. For the extract node, we are basically entering this method with a node name and an array, and only to extract all the data under that certain tag or node. A tricky part here is with some elements we have, like in both EQ and SSH file, and for these elements we are using a dummy variable to be like a separator to be dealt with later. Another tricky part is when the attribute exists on the node child. So we developed this method to go through it and gets that certain element from under that node. Line elements and transformer ID to winding and winding elements are used for the purpose of calculating the Y matrix. The read SSH class follow the same, and an extended version of the read EQ file which follow the same and has read SSH file and to extract the data on the node. Going back to project 1, we have parse imported files, which basically parse both two objects and then extract the nodes and extract each data node and create a node list for every tag name. Then we have load database, which basically go and create a table on the database and then insert the array to the table for each tag name. If we are to go into that database class, we can see that this class basically has multiple methods to make dealing with the database easier, such as create table name and insert in table, as which can be shown here.
I will be talking about calculating the Y-box matrix. So to make everything easier, I've divided the procedure into first steps. The first step is to extract all the information into array list, so the connectivity node, the terminals, the status of the terminals, and also the AC line segments, which holds the base voltage and also the line ID. And for the second procedure, we would like to remove all the open breakers and all these terminals that are not connected, and also we would like to merge all the connected terminals via a connectivity node together to form a group, and then merge them further into buses by observing the breaker status. And for the third procedure, we are going to observe the line segments and find the corresponding buses that are attached to each line segments. And we will do the same for each transformer, however, it's more trickier for this part. So, going into the first step, we would like to just collect all the connectivity nodes, terminals, thermal statuses, and assign them to the corresponding array lists. And for the AC line segments, we would like to get the line voltages and also the line IDs for the step 2 procedure. And for the second procedure, we would like to check the terminal status and remove all breakers that are open, which is basically done. And the same thing for the terminal status. And for the winding terminal replacement, we would like to remove all the connectivity equipment that are referring to the winding terminals and switch them to referring to winding terminals instead of transformer terminals, so that we can use them easier for the step 3 to step 4 procedures. Next, we are going to group all terminals that share the same connectivity nodes and take all these groups and group them further into two groups that are connected to each breakers. They are connected to each side of the breaker, and regroup them in order to form all the buses attached to. So it will be a 5 by 5 matrix. 5 buses that correspond to 5 by 5 matrices which will be corrected here. Further, in step 3, we are going to loop through all line IDs, AC line segments, so that we could check each side of the AC line segments using terminals that correspond to the corresponding bus attached to each line segments. So, and we would like to record all these using indices. So each line that is attached to the bus, we would record this, and then we would loop again and find the other bus that is attached to the same line segments. From there, we are going to calculate the base voltage using the line ID for this specific line, and then we would obtain the base impedance. From there, we would we would subtract all of the non-diagonal elements and then add all the diagonal and non-diagonal elements for the corresponding line admittance and shunt admittance, which are calculated using this. Here. So we will just find all the R and X and J for all the line admittance, and then we would retain all the line admittance as an array. Next, for the step 4, which is a similar step to step 3, however, for this step we are going to loop through all the transformer IDs and find the corresponding windings that are attached to each transformer. And then from these windings, we would like to get all the terminals that are connected to each winding. Then we would use all the terminals and loop through them so that we would find the attached bus that is corresponding to each terminal. So we need two buses that refer to the same terminal that is attached to each winding. And then we would like to record these indices as well, the same thing we did for the previous step. So this is the indices that correspond to the bus, and then we would like to record some indices that is connected to another bus. From there, we take each winding and find the corresponding base voltage, and then we use both of them to calculate the transmittance admittance that is for each winding. And then we would like to retain all these values as an array as well. So it's basically the same as the thing that we did for the third procedure. From there, we are going to subtract all the non-diagonal elements and for the line admittance, and then we add all the diagonal elements for the line admittance as well. However, for the shunt admittance, we add the shunt admittance that is corresponding to each bus individually. So for the bus 1, we add the winding of the first admittance, and then the second for the second as well. Then we are going to form the admittance matrix that is going to be used today as well, which Amar will be talking to you next.
Finally, for the show Y matrix, we are presenting the matrix through the class called YBusGUI, which can be seen here. That is accepting two arguments to return a table created on the side of that argument. There is a scroll pane here which was made as it was intended to make the code applicable for a system with large amount of buses and thus a large Y matrix. So if we are to execute the program, we can find that the Y admittance matrix